Hello, welcome back to Blender Sushi LiveENODING. In this episode, I'm gonna do a little bit of improvisation using Spreadshock add-on. So basically, the idea is to have a little bit more control over a box node in Spreadshock. Okay, you can see here at the moment I have 96 boxes, and then each boxes is actually kind of on the ground. It's on the grid. They are all standing on the grid, and they're all having different size of boxes. And I will explain the whole setup. It's actually very simple, but I think it's very important concept for beginner. Even for myself, I just found out, okay, that's probably a good way to do this. So I will explain it from scratch. Okay, so from an empty scene, I will create a new Spreadshock node tree in Blender, and I will start with a box object and a viewer draw. So by default, this box is actually placed at 0, 0, 0. The center pivot of the box is not at the bottom, it's not at the base of the box. And you can size it, you can make division, but you don't actually have control over the size, the actual, like the XYZ scaling of this box. Compared to rounded boxes, rounded box actually have control with a vector size here. If you give like a random vector size, it's gonna resize the box accordingly. This guy doesn't have it. So how do we go about doing that? I just remember actually you can use a matrix apply. So this vertices of the box goes into matrix apply, and with the matrix in like this, we can actually control the scaling. So by default, the scaling is 1, 1, 1. That's give us this box with the same length of XYZ, but we can change it. So XYZ, we can scale it in any way we like. So that's actually the whole idea here. I'm gonna use a vector for the scale. So 1, 1, 1 give you that. Increasing it in the Z give you that, and scale it in X, in Y. You can randomize it easily. But how about placing it on the floor? Now, placing objects on the floor is I talk about it in one of my LiveENODING videos. So basically, if you get the bounding box of this object and then divide it by half, this object should move like half of this bounding box in the Z axis, and then the object is going to be on the floor. In this case, for the box, if we scale it in the Z, actually, let's say we scale it 4 unit in the Z, this box needs to move up by 2 unit. So I'll show you what I mean. So in order to place this box on the floor, on the grid, we need to move this up by 2 axes. If this size should be always be 1. So now this object is on the floor. So that's the basic idea. I will use a number node, and I will use a float here, and I'll make it 4. Plug this into the scaling of the Z. The X and the Y doesn't matter, but we only care about the Z for now. So the scaling in the Z should affect how this object is placed in the 3D based on these vector locations. So this should be half of this Z, this number. So math mk2 divided by 2, this goes in there. This should actually work. I think divided by 2. Did I do something wrong? So that's 4. 4 divided by 2 should be 2. Oh, okay. This should go in there. Okay. There you go. So increasing the size, move these objects half of this value. So now we always have box that's always placed on the floor. So that's good. I will save this. So this is a Spreadshock place box on floor. And I'll save new version right away. And what we want to do next is to be able to create bunch of box all with different sizes, and they are all should be on the floor. So I will have a plain grid. This plain grid points, I will use it as the instance points for the box. So now we have 4, for example, but we want to center it to look nicer. Okay. So now 4 by 4, we have 16 boxes. They are all the same size. I'll turn off the points. They are all the same size, and we want to randomize the Z, for example. It's pretty easy. Instead of a number, we're gonna use random number. I'll use float, plug this into that guy, so we can have a random number. No, it doesn't work yet. That's because we need to do something here. If you look at the points, it's not correct. We actually need to do some kind of polygon repeat. See the number here, 10, 16. That's actually wrong. We actually need 16 here, depending on the number of the matrix points that we plug into this guy. So it's supposed to be 16, 16, and 16. We can fix this by using list repeat for the polygon. Make this 16, and it should work. We can bake it. Yeah, but there's an easier way to do this. We don't need to use list repeat, so we simply use apply matrix, but select the second one, matrix apply. So polygon data goes in here, and then with this matrix, we can use matrix in. This plain grid goes in there, and it just works. We don't need to use list repeat. And join or not is up to you. By default, it's join, so this guy will be joined. Yeah, so that's basically the idea. The number of random number, and it should match the number of point here. So we need to use a list length and get the total number. So 16, okay, 16. So imagine this is like this. The total number of these points tell how many boxes we should have. Let's go in there. So now we can randomize the height of the box. We still have control over the X and the Y of the box. And the nice thing is they are always on the floor. They are always correctly placed on the floor, on the grid. So let's add another random number. This goes to the size. Another one. Randomize the seed, and this goes into the X, and this one goes into the Y. If you look at it from the top, orthographically, so we can see this is all our boxes. We can control the X, minimum and maximum. We can control the Y, minimum and maximum. We can increase this number, and they are always on the floor. Increase the height. Sometimes this froze a little bit somehow. Maybe the join operations is a little bit slow. I don't know. But once it's calculated, it should be fine. So we can have some kind of super basic city once again. But of course, a building needs more details. This one is just boxes. Should be okay for some kind of prototype of a city. So yeah, this is boxes being arranged on a grid. They're all different sizes randomly, and we can randomize the grid position. Oh, actually, no, this should be before. We don't actually need to use matrix in. We can just plug that in. So we can randomize the position of the grid in X and Y slightly, so they're not totally on the grid, slightly off in Y, slightly off in X, and we have kind of more like mesh, city mesh. That's a bit random. So I'm kind of wondering what's actually slowing down this setup. If we save this and look at the preferences, file, preferences, and find Spreadshot and print the heat map, I was hoping to be able to see something here. File, preferences. Maybe I need to save the setting and update Spreadshot. What? I cannot see which one. Okay, we can see here in the list which one is slow. Maybe the one that's slow is this guy. Team. Okay, it doesn't work. Anyway, it's one of these might have slowed down Spreadshot at some point. I don't know, but now it seems to be working fine. So I can increase the number, like crazy number, 40 by 40, 1,600 buildings generated procedurally. So yeah, I think this is very basic but very important concepts. How to scale boxes into random size and then place it on the floor. Placing it on the floor is not easy concept for me, but maybe for you it's easy, but I think it's very useful if you understand it really well. So yeah, so we start with a box and we scale it randomly and then we place it randomly using plane, and then this is what we have, 1,600 random boxes. Okay, so that's pretty much it for this live coding. Let me know what you think and I'll see you in the next video. Thank you. Bye.